Okay guys, so we are going to go over questions 2 and 3 from quiz 4 in this video. I'm going over the yellow quiz. If you have the green quiz, I will show you those answers at the end of the video. Okay, so number 2 says we have a reduced augmented matrix listed below. We're using the variables x, y, z, and u to represent the number of freshmen, sophomores, juniors, and seniors in a math class. Okay, so the other thing it says in this problem is we want to find the general form of the answer. Now, this phrasing of general form pretty much suggests that it's going to be a parametric and that she wants it written in the general form of being in a parametric, rather than the specific form of when you can plug a value in for t and find a specific solution. So let's see if that's true. If we read across our rows and turn them into equations, we get that x minus 2u is equal to negative 5, y is equal to 10, and z plus 4u is equal to 33. Okay, so looking at these equations, did we solve for our variables? Did we solve for x, y, z, or u? No, we didn't. So we don't have one solution to our equation. Now, do we have any contradictions? No. We also don't have any contradictions. We don't have anything saying that 0 is equal to 1, okay? So if we didn't solve and we have no contradictions, what's left is a parametric, okay? So we know that we have a parametric solution. Now the next question becomes, what variable do you make equal to t? And remember, we're going to look at the columns. So if you look at the column for the variable x, you look at the column for the variable y, for z, and for u, and I want you to decide which column does not have a leading 1. You should pick u. U does not have a leading 1 in it, okay? Both x, y, and z all have leading 1s in their columns, okay? U does not. Remember that this last column does not count, okay? We only care about the columns that are associated with variables, not the column that comes on the other side of the equal sign, okay? So since u does not have a leading 1, we're going to set u equal to t, okay? Then we want to look back at our equations. In every place that there is a u, we're going to change out for a t. So that would be here and here. So we're going to go ahead, cross out that u, and make it equal to a t. Now your next step is to solve for x and for z. Because remember, when we write our parametric, we want it to be x, x, y, z, u. So you need to know what are x and z equal to in terms of t. So, when we solve for our variables, you're going to move over this 2t, and you get x is equal to negative 5 plus 2t. Y is equal to 10. We don't have to do anything with that. And if you move over this 4t, we get that z is 33 minus 4t. Okay, so now we can write our parametric in the form x, y, z, u. So, first we have x, negative 5 plus 2t, because that's what x is equal to. Then we have y, which is 10. Then 33 minus 4t is our z. And don't forget, you still have to put what u is equal to at the end, okay? U is equal to t, so we just put t there. Now, where a lot of people lost points on the quiz was this next part. And if you remember me talking about in class, I gave points back for it, okay? Because I didn't feel like you guys were really tested very well over it in the videos that were given, okay? So, after you write a parametric solution, we always want to define what numbers can t be equal to. A lot of times we'll say that t is any real number, okay? You can't always say that though. So at this point we want to say where t is equal to what? What can t be equal to? So our main constraints in this problem are that we have freshmen, sophomores, juniors, and seniors, okay? So mainly, we can't have any of these values be negative, okay? It's just not going to work. We can't have X, which is the number of freshmen, or Z, which is the number of juniors, be a negative number, okay? So we're going to solve and make sure that T does not end up being a number that would give us a negative solution, okay? So the way to do that is pick our variables that have T within them, like we have here for X and for Z. Then I'm going to say that X, which is negative 5 plus 2D, has to be greater than or equal to 0. We can't have negative freshmen. In the same respect, 33 minus 4T needs to be greater than or equal to 0 because we can't have negative juniors, okay? So then you're going to solve for T. So if you do that, let's look over here first. If you move the 5 over, you get 2T has to be greater than or equal to 5. Divide by the 2. T has to be greater than or equal to 5 over 2. And if you put that in regular terms as a decimal, you would say that T has to be greater than or equal to 2.5. Okay, so let's look over at this side. You add the 4T, and then you're going to divide by 4. And when you divide by 4, you notice that I wrote T on this side, so I'm keeping with the narrow end is still pointing towards the T. It just looks like I flipped the sign because I moved the location where I put T, okay? So we have that T has to be less than or equal to 33 over 4. And if you divide that on your calculator, you get that that is 8.25. So, to make sure that we don't get a negative number of people in any of these constraints, this is what we have to do. We have to say what can our T be equal to so that we don't have any negative people in this case, okay? So if you were to draw this on a number line, we have that T has to be greater than 2.5, greater than or equal to 2.5, or less than or equal to 8.25, okay? So we're in this range of 2.5 to 8.25, but we can't have a fraction of a person, okay? So we need to decide, should we round up, should we round down, based on where we're allowed to be. So here, we're starting at 2.5, and we're saying T can only be greater than that. So we can't round down to 2, because that would make us have a negative value. So we're going to round this up to 3. And here, in the same way, we can't go above this constraint area, so we'd have to round this 8.25 down to 8, okay, to the nearest whole number. So our first part of our solution is this parametric, and the second part is where you say where T is equal to anywhere from 3 to 8, okay? So in order to write the solution for this problem, you need both the parametric portion of it as well as what T can be equal to. You need both in order to be correct. Okay, so now we're going to move on to question 3, and once again the answers for the green quiz will be at the end. So, our number 3 says we want to find the solution or the feasible region for the system of linear equations, okay? And in this case, we're going to shade by reverse shading, and so that means that we are going to shade the false side, okay? So, as you can see, our lines are already all set up on this graph, so you just need to decide which direction are you shading for each line. So I'm going to start with this 4x plus 7y is less than or equal to 28. That is this line right here, and we need to know, should we be shading on the upper side of it or the lower side of it. So let's pick a point. Remember, the easiest point is 0, 0. So I'm going to take 0, 0 and plug it in. I get 4 times 0 plus 7 times 0 is less than or equal to 28. So we're saying, is 0 less than or equal to 28? And the answer is yes, it is. So this side, which contains 0, 0, makes my solution true. So I'm going to shade the other side, the false side, which happens to be above my line. And that is how it should look when you shade, okay? Then we have 5x plus y is equal to 0, okay? Now we can't pick 0, 0 in this case because it's on our line, so we need to pick another point. I'm going to pick 1, 2, okay? So that's the point I'm plugging in. I'm plugging in a 1 for x and a 2 for y. So if I do that, I get 5 plus 2 is greater than or equal to 0. So I'm saying 7 is greater than or equal to 0. Is that true? Yes, it's true. So the side of the line containing this point makes my solution set true. So I'm going to shade the false side, the other side, which is over here in this direction. Okay. And lastly, we have that x has to be less than or equal to 1, okay? That's saying that x has to be less than or equal to 1 is on this side. This is the true region. So we want to shade the false region, which is where x is greater than 1, which is on the right side of this vertical line, okay? So that's where you'll shade, on the right side. Now, another part that a lot of people got points off for is it says you need to label your feasible region with an S, okay? You have to say, where's your solution set? Our solution set is this triangle right here, okay? The next thing you want to do is you want to label your corner points, okay? We have 3 corner points, A, B, and C. Now you could have labeled them going the other way, that's fine. An important thing to note is that these points here and here are not corner points. Remember that a corner point is when 2 lines from 2 different inequalities are meeting each other, okay? So you can see at A, the line 5x plus y equals 0 is intersecting with 4x plus 7y equals 28. In the same way, B is intersecting with 4x plus 7y equals 28 with the line x equals 1. Okay? And C is intersecting x equals 1 with 5x plus y equals 0. Alright? If you were to label these 2 locations as corner points, that's not where we're meeting 2 different lines from 2 different inequalities. Okay, so those are not corner points. So now what you want to do is solve for the exact values of our corner points. So I'm going to start with A, which I already told you was 4x plus 7y equals 28, where that line is intersecting with 5x plus y equals 0. And the easiest way to do this is to put it into a matrix and solve using RREF. So that is what I'm going to do. This is the matrix that we put it into, and when you do RREF, this is the matrix you'll get out. So I have a feeling that some of you might have forgotten how to do this. So I'm going to go over it with you guys on the calculator. Alright, so let's go over this really quick. Okay, so we're going to go to second matrix, scroll over to edit, and what's the size of our matrix? It should be a 2 by 3, right? The first number is our number of equations, the second number is our number of variables, okay? So we have 2 equations, 3 variables. So you should enter 4, 7, 28, 5, 1, 0. Then I'm going to second quit, go back to matrix. I'm going to scroll to math, and I'm going to use the up arrow until I find RREF. Then I'm going to put the name of my matrix, which I use matrix A, and I'm going to press enter. Now, remember, we don't like all this junk, okay? But it's okay, because your calculator will fix it for you. Remember, we just need to press math and then press enter, because we're on frac, okay? and you press enter again, and your calculator will turn those into fractions for you. So you can see we get that x is equal to negative 28 over 31, and y is 140 over 31. So those are your answers for the corner point A, which you can see I have listed right here. Okay, you should have got that off the calculator. This is the easiest way to do it. So we're going to do the same way for B and C. So as you can see, B is where x equals 1 is intersecting with 4x plus 7y equals 28. When you put that into a matrix, you should get out the point 1, comma 24 over 7. And in the same way, C, when you put this matrix into the calculator, you should get the point 1, comma negative 5. And those are your answers for the yellow quiz question 3. As promised, here is the answer for question 2 on the green quiz. You can pause it if you need time to review. And here's the answer for question 3 on the green quiz. Alright, I hope this helped you guys understand what you may have done wrong. If you have any further questions, you can always come see me or Nate in our office hours.